Okay, so we do have your test on Tuesday. So today we're going to go over the main 3 types of questions that you will have. The first question is, oops, wrong computer. That's going to be confusing. The first question is going to be exactly like this. Does anybody want scratch paper to work this out? I can't come over these wires. So. Anybody over here want scratch paper? Pass it back. Pass it around. If you want this to be a study tool, you could maybe kind of sketch what you're seeing in the circle. Up to you. You guys in the back want scratch paper? You're good? All right. So this literally will be pretty much exactly what your test will be like. It'll be the same format. Thank you. But different numbers and a different picture. Okay? So I have given you the field of view at low power. And I need you to estimate the size of a pair of paramecium. This is, what you're seeing here is paramecium conjugation. So they're coming together and switching DNA. So a pair of paramecium, which I have circled for you in the orange circle. So estimate the size of a pair of paramecium under the high power of 250x.
Can I use my phone as a pencil?
You may. Just remember on Tuesday, you need an actual calculator, would be amazing. I have a few extras, but I do not have a class set of calculators, so try to bring your own if possible. But for now, you can use your phone. You'll have to borrow one, but you might have to share with other people. It's pretty quiet, which is awesome, but you can work together if you want. Who wants to tell me the first step we would have to do for this question?
Multiply
5.8 times 10
over 250.
So you're saying use this equation. Okay, so I'm going to say number 1, you have to find the field of view at high power. Very good. Perfect first step. Everybody do that. 5, using this equation. Okay, you have all the information you need for that.
Yeah, but I'm gonna go to 6 first.
Yeah, but I estimate that.
Also, like
Okay. You're gonna take the.
so that's
Like we're not supposed to you take dude, first like I went last week the lower number. Oh, never mind. The lower. How do you know? I'm trying to help.
actually, I have not worked it out yet. Are we ready for the next step? Once you find the field of view at high power, what would you probably do next?
Probably count these circles that fit into the circle.
Does that make sense? Count the circles.
Yeah.
Okay, good. So draw/count circles. I'm going to put how many paramecium would fit.
I'd say 3.
I'd say 3.
I'd say 3.
Would fit in the field of view.
Actually, it depends on their positioning.
I agree with that. It's difficult. So you got to kind of
I'd say 3.
imagine.
I'd say
Okay.
3.
Once we know how many fit, we're going to do what calculation?
So what you're gonna do is 3 to the
Oh, 1.
3 times 1 over
1.
Yeah, one.
Tell me without numbers.
Okay, so you're gonna take the you're gonna put in a fraction
You're
Okay.
gonna get a high power.
and
There's
then
only
multiply it.
one.
So 1 over How many would fit?
Multiplied by the answer of the high power.
Times
High power.
field of view high power. Okay. Wonderful. I like it. Beautiful. Now's a good time to ask for help as I am wandering around the room.
Wow, I got a great number. We have to round them up, right?
You're finding the actual size, so I would go with the decimal places you're given in your field of view. Round to that. We still have to go over all those rules, but okay, I'm gonna draw some circles here.
Is there a science portion for the SAT? There is? I know there's a big science test. Wait, Miss Lizzie.
Huh?
No,
I don't know anything about that thing. I don't remember that thing.
What did you get on it?
I know I got pretty good, but I was counting on my AP Calc scores and my 4.0s to get me in college. I wasn't too concerned about SATs because I had a very good 4.0 record.
Oh.
And I got a 5 on the AP Calc test.
Oh.
So I got into Cal State Long Beach, and I was still happy about it.
5's the best you could do on AP, right?
Yeah. And fun fact, my husband only got a 4,
Oh.
but he knows way more about math than me now. But that's like the one math achievement that I can hold over his head. Yes.
Whatever happened to the head of the tiger we used to have?
Oh, I have it. I should bring it. It's in my garage.
You should.
It's in my garage. And it's still blown up. I'm surprised with all that heat.
It's been years.
It's been blown up for at least 10 years or more.
Who blew it up? That's my question.
I did. Over 10 years ago, one time. And it still holds its air. Yeah.
Okay, like I haven't diffused it anyway.
Huh?
I haven't diffused it anyway.
It might be slightly, I haven't checked it since it's been in my garage, but it still looks full-ish. Okay, let's do this math. Find the field of view at high power. What did we do? What numbers? Tell me the...
I said 1/3. Oh, no.
5.8
times 10
times 10
over 2.
Don't forget your units.
millimeters.
Sine 10. Wait.
Okay. Tanya, what did you get for that?
0.23.
0.232?
Yeah.
Yes? Yes?
Yes.
0, I'm going to go to the same decimal place we started with, so 0.2. 0.2 what?
Millimeters.
Millimeters. Wonderful. Everybody good on step 1?
Yeah.
Perfect.
Oh, you're supposed to
Draw/count how many paramecium would fit in the field of view. What did we estimate?
We said 3.
I'm saying a little less than 3. Look at that little.
That's like 2.8.
Okay. All of those numbers would be fine. On a test, I would probably take 3 because we're not even going through the full diameter here, right? So really what I should do is take all 3 of those circles if I really wanted to do this right.
Yeah, it has to be diameter.
Ooh, just kidding. Just kidding. If I really wanted to do this right, I would take and try to resituate.
Yeah.
And it's 3. I was right.
I knew
You're
it.
so far out.
Dude, I already know 3.
So again, if you did 2.8, 2.93, it actually worked out perfect. There's a little bit on the end still, but we'll go with 3.
Actually,
Yeah, you
because
can
that line
Yeah, I
doesn't
can spin it a little.
Okay.
Yeah, I told you.
Okay, we'll do 3. So we drew/counted how many paramecium would fit in the field of view, and that was 3. Okay. So then what do? We have to do 1/3 because we only want the size of one of them times
0.2.
0.2. Always remember your units. Good. What's that?
0.06. 666.
Sorry, this is like behind my desk.
It would be 0.6.
0.06 should be rounded to
1.
1. 0.1. I know. I'll rewrite it.
Oh,
0.1 what?
Millimeters.
Thank you, millimeters.
100 micrometers.
Okay, so I can't jump the cords. I'm sorry. Can you see this?
Yeah.
Okay, so the third step, we did 1/3 times 0.2 millimeters. Because we want 1/3 of our field of view, right? So our field of view was 0.2 millimeters. And we want to know 1/3 of that. So that equaled 0.1 millimeters. Just for funsies, how many micrometers would that be?
100.
Did you guys already do that in your paper?
Yeah.
Yes, you're so good. 100 micrometers. Perfect. Beautiful. All right, I'm actually going to take a picture of that because would that help if I reminded you that later?
Yeah.
Too?
And it would help.
That's it.
Oh. That might be asking a little much.
Yeah, so 0.7.
Damien, what that image saved in your drawing?
Alan, can you take a nice picture of that, please? Thank you.
Well, all this, even the question.
Just the screen, and then we'll do this part next. Okay.
Do a little panorama.
Panorama. Thank you.
Take a selfie.
Okay, we are going to switch now to the packet, and I have to hang my head in shame because I did it wrong.
Oh, the teacher got it.
The bottom one was a terrible example. Take big X through it.
Teacher got it wrong.
The paramecium was terrible. Anybody know what we forgot to do?
No.
Yeah.
I would say exit out. We have like 10 more practices, so just know that don't look at that one. The top one is perfect. The bottom one, I'm going to do this. Bye-bye. Icky. Bad example. My bad. Terrible moment for a teacher.
Why?
We forgot a step. If you want to try to find it, that'd be...
I think we forgot. I'm just kidding. I'm sorry.
All right. I have things to send you later. Wonderful. Okay. So let's do the two that you were supposed to do for homework and see how you did on
We
this.
did wrong.
Wait, two?
You were supposed to do these two for homework.
On the paramedic, what did we do wrong?
We forgot. I'll point it out when we do this one. Okay. Guys, we have minimum day, and I need to make sure we get all this in because I am not changing the test again. Okay, so listen up. So, you should all have a ruler because you were given one in your planner.
Oh.
You have one in your planner. I actually freaked out because I didn't think I had a ruler at home, and then I found one in my junk drawer. Yes. Okay. So the one equation that I need you guys to memorize is what? I have it on the board.
Equals X over.
Size of drawing. I'm going to do SOD because we all like short things. Sod over what?
Sod over
Magnification.
Sod over sauce. That was terrible.
Sauce?
Sod over sauce. I hope you guys can see that. Can we actually turn the light off? I better do this in pen. Darn it.
That's drawing, that's specimen.
All right.
Oh.
So I am specifically doing different colors for a reason. You can follow along or not. That's up to you. Blue. Okay. So we can use this equation for the whole packet. Magnification is, oh, I did have the size of drawing over the size of the specimen.
That's kind of.
I was hoping it wouldn't.
Oh, you're good.
But on the back sides, it's not good. Okay. It's gonna be okay. So let's start with the size of drawing. That's the easiest part. So, whoa. Actually, I do need a ruler. Somebody can grab me one,
There you
please.
go.
Thank you. P. Size of specimen. Okay, let's see. You measured how many?
Millimeters.
How many millimeters?
66.
I already knew that. I just knew.
Anybody want to defend their answer with something different?
You have to measure them.
On my scratch work, I did 65, so we're gonna go with 65. But if you want to do 66, do it. So our SOD is 65 millimeters. That is so gonna bleed. I'm gonna go back to pencils. Sorry. My indecisiveness.
I'm having a brain blast.
Okay, 65 millimeters. Cool.
Yeah, I agree with 65.
Next thing we need to do is figure out the size of the specimen. Now this is more difficult.
Need to measure the.
Yes, we need to measure our thingy. What is thingy called?
The size of scale.
Scale bar. I'm so sorry that I'm in you guys. If you want to move tables.
Yeah.
1.5
No, that's
centimeters.
1.5 centimeters. So what?
15 millimeters.
I think I went with 16. Can we see 16?
Yeah.
16. Okay. So this scale bar is 16 millimeters. What does 16 millimeters represent in real life?
The size of that.
So 16 millimeters on our ruler represents 100 micrometers, right?
Oh.
Okay. So, for this one, I'm going to do it one way. I'll show you. You can convert in different spots. 16 millimeters is how many micrometers?
0.1, right? Oh, sorry, not 16,000.
Go the other way. 16,000 micrometers. Remember, if you're going to a smaller unit, your number should be bigger,
Yeah.
right? Because it takes more of something small to equal something big. I hope that makes sense. If you're going from small to big, your number should be smaller. So it's like flip-flopped, kind of. Okay, so we know that 16,000 micrometers in real life represents 100 micrometers. Sorry, on our drawing represents 100 micrometers actual size. So what's the next thing we have to do? It's similar to number 2.
Oh, we have to move.
Circle.
We have to divide by something, but first we need to know how many scale bars fit in our length. Okay? So the next thing we need to do is how many scale bars fit.
So we divide 16 by 65. Or the other way around.
This was your one.
Turn what?
You get the nose?
No, not the light, the brightness.
On this? I don't think I can. It's on or off.
I'd say 5 of those.
Is it on the flicker? You want to see on the flicker?
What's a flicker?
You don't use the word flicker? What do you use?
The remote?
It's a flicker. To flick channels.
No. No. What is that?
I don't see a dimmer on here.
Like liquor.
Yeah. I'm sorry, you guys. I don't know. Ooh, do I have a green pen? I have a blue pen.
Actually, that's not allowed in your lab.
Is that better?
No.
I don't know how to fix it, you guys. I'm sorry. How many scale bars fit? Okay. So we need to convert our 65 millimeters to what? We want everything to be in the same units.
6.5, no.
Is it 65,000?
Would be equal to how many micrometers?
65,000. Oh my, I already figured it out.
Okay, 65,000 micrometers. So If we want to know how many of these scale bars fit, what math do we do?
Divide
65,000.
divided by 1600.
65,000 micrometers divided by 16,000 micrometers. So how many scale bars fit?
I'd say 5. Approximately.
We need an actual number. Calculator people, go ahead. 4.06. So 4.06 scale bars fit. Okay?
Theoretically speaking.
So this is what we forgot to do on step 1. I didn't do this part. So if 4.6 scale bars fit, and we know how much each scale bar is representing for the actual size, what do we have to do? We want 4.06 scale bars, right?
Yeah. Do we not round?
4.06.
Yeah.
Wouldn't it be
Turtle stick.
4.06 times what?
4.06 times 6?
100. Because we know we have 4.06 of these, right?
Yeah.
And each one represents 100 micrometers. So we do 4.06 times, times 100 micrometers. And that will be our size of specimen.
406.
So 406 micrometers. Okay. So now we have our size of specimen and we have our size of drawing. Now we just go ahead and plug that in to our equation. Okay. So we plug that into our equation.
So are we doing this? We're doing this micrometers. So
6,500.
Yes.
100 micrometers.
You could, or you could keep it in millimeters and do it that way, which I'm going to do the next one.
65.
So we do 65,000 micrometers divided by 406 micrometers.
And what is that?
What is that, calculator people? What? 160.1. So with this one, we're not basing it on an estimate, right? We're basing it off actual measurements calculations. So I'm going to keep it as 2 decimal places. So for what was it? For
160.09.
Do you not round?
shouldn't it be 10? I came up to 10.
Yeah, that's what I was thinking this whole time.
160.10. What's our symbol we use? Mag, which is X. Very good.
Do you have to put the extra 0?
You do not have to. I would say it's fine. Do you have other colors of these? Because this won't bleed and it will look better than my pen. Yes.
So what are we rounding to for the decimal? Is it the 10th?
For this test, since I haven't taught you all the rules, whatever you round to is fine. But I would say you don't have to go past 2. We don't need all the decimal places. Okay, so let's do this again. And then I'll give you a break on this on the third type of example, which is a million times easier. Oh, thank you so much. Woo!
Can you use pink?
Maybe. All right, so we are going to start with our same equation, okay? I would say write this equation every single time, so it's in your brain. So mag equals what?
Size of drawing.
SOD, size of drawing, over
Specimen.
size of specimen. Very good.
SOS.
Size of specimen. Perfect. So let's start with the easy. What is our size of drawing? I've given you the line that you need to do.
5 micrometers. 58.
Inches.
80.
Let's see. What did I do last night?
Are we counting that little?
I did go 58. Nope. On a test, I'll try to make it super clear. Honestly, with a test, since they're going to be printed in black and white, I'll probably put a color copy up here so you can see exactly what line I want. Okay, so that'll be clear. So good. So 58. So our SOD,
58 millimeters.
58 millimeters. So let's try this way. Let's just keep it in millimeters this time. Okay? You guys can choose on a test if you want to work in micrometers, if you want to work in millimeters. I think it's pretty much the same either way. Okay, size of specimen. What's the first thing we have to do?
The scale bar.
Scale bar, very good. What's the size of that?
15.
16? What did I do?
Oh my God.
I did 16. So the scale bar is 16 millimeters. Okay. So if we want to say 16 millimeters on my drawing is representing what in real life? 5 micrometers. But we're going to work in millimeters. We need millimeters. So 5 micrometers really equals
0.005.
Yep. 0.005 micrometers. Sorry, millimeters. Okay. Huh? We're multiplying by 1,000. Sorry, we're dividing by 1,000.
Where do we get the 500?
Where are you guys seeing 500?
Up there.
That's an SOD.
Wow.
Oh my gosh.
Sorry. I'll try to make that more clear next time. D. That looks more like a D. Okay. All right, so what's our next step? First step, we know the size of our scale bar. We need to figure out what? How many scale bars would fit in our length? Okay, so we have to do math, right? We know our length. So we would do what?
0.005 times.
We want to know, we have this length, and we want to know how many of these fit.
Oh.
You divide.
Yes.
So we would do 58
Oh, 58
millimeters divided by,
0.005.
no,
16.
16.
3.6.
Yeah,
3.6?
Yeah.
Just double checking.
Or you want to add to it.
3.63. Point. Okay. So we know 3.63 scale bars fit. 3.63 scale bars. You don't have to write all of these words, but I just want to make sure it's clear to you guys. Fit. Okay. So now that we know we can fit 3.63 scale bars, how are we going to find out our size of specimen? Multiply. So we take this number, 3.63 scale bars, and if we're going to work in millimeters, we need to multiply by millimeters. 0.005 millimeters. Okay?
Oh.
All right. So what is that number?
0.018.
0.018.
Yeah,
So 0.2
yeah.
Of course, actually.
millimeters. Okay. So now we have our size of specimen is 0.02. And our size of drawing is 58. Last step, easiest step, we plug that into our equation.
Dude, I'm actually understanding.
Whee, good, because we have lots more practice to do. All right, so we just plug it in. So we have 58 millimeters divided by
0.02.
0.02 millimeters. Our millimeters will cancel, and our answer is
2,900.
2,290.
that's not what I got. Oh, but I kept a bunch of decimal places and I shouldn't have.
I can't erase the pen.
Anyways.
Yeah, no, that's right. Okay. 2,900. What?
X.
Perfect. Okay.
It's very large.
So I want to take a minute and show you your next example, which is like
Easy.
much easier than this example.
What?
This is your harder. I think this is, I don't know, what do you guys think was harder? Our warm up of the day or this?
This.
Okay, so in terms of easiness, the one we're about to do will probably be the easiest question. Then this will be second, and then this will be your hardest. Okay, so when you, in terms of studying, know that if you feel like this is the hardest, maybe do most of this practice. Okay, all right, we are going to go now to the back of the first page.
What? Oh, no.
You are looking at a hydra and a volvox.
Hey, I do love those.
You did.
You look a little different though. I can't fucking do it.
It's a hydra.
Now this one, I want you to X out a piece of information.
Where?
Where?
Please X out your scale bars. We are not going to use that information for this type of question. I need you to add a piece of information. We are going to say that the hydra is an image drawn at 20x. Okay? So for this example, you will be given the magnification of the drawing.
Oh.
And what's the other piece of information we can easily get with our ruler?
Specimen.
Size of the drawing. So we have mag and we have sod. Can we find sauce?
Yeah.
Yeah.
Perfect. Your magnification for your volvox is going to be 150x. Okay. So what's our equation? We are not changing the equation. What's our equation?
SOD over SOS.
Sod, size of drawing, over
Size of specimen.
size of specimen.
But we can tell it like
Same exact equation. How we solve for it will be slightly different, but I know you guys can do it. You are that smart. So let's go for it. I want you to measure the height minus the tentacles.
23.
Height minus the tentacles.
All right, I got you. It's 50.
So what's our sod?
Like
56.
Shut up, David.
72.
72.
I got 56.
Sorry, I drew my line a little long. Stop at the bottom of the foot.
I got 56.
I did 56 last night, so we're going to do 56.
Yeah.
Would you be okay on a test if you did 55?
No.
Yes. Okay. Easy peasy, right? What else do we know?
The mag.
With the mag. So we're ready to fill in our equation and we're almost done. Don't we like this question?
Yeah.
All right. So we do what? 20. You just leave it as 20 equals 56 millimeters over. Now you can either write an X there if you want to go full algebra with just one variable. I'm going to keep it as sauce just so I know what I'm doing in my mind. Just think of sauce as one variable, right? Okay, so what do we have to do to solve for sauce?
Look,
You have
to get the scale bar way down.
Okay, I'm multiplying both sides by sauce, right? Yes.
What?
Sauce cancels. Now I have sauce times 20 equals 56 millimeters. Then what do I do? Subtract.
What are you talking about?
That's a multiplication there, my friend.
Oh, divide.
Divide by 20, both sides. Sorry, I should have rewritten that. That was bad.
2.8.
So now our 20s cancel. And we really are doing sauce equals 56 divided by 20, right? 56 millimeters
I got 2.8 for that. Yeah, me too.
divided by, gosh, it takes forever to do different colors. Okay, what did I get?
Now, is that really necessary? Is that necessary?
Yeah, we brought-
Oh, if you don't need to write all that out now.
Yeah.
I just want to make sure you guys know. Okay. If you just want to show me that sauce equals sod over mag, that's fine. But I just want, because in terms of memorizing an equation, memorize this, right? And then plug in a sauce. Yeah.
So is that it?
But 56 divided by 20,
Oh.
2.8.
why did I not get 2.8?
You're doing it.
Because I did something wrong. What did I do wrong?
56 divided by-
I know.
He's going to be disappointed.
He'll be fine. Just don't tell him.
You can do it in your head. It's
What is it? 2.8 millimeters?
Yeah.
Or
2,800 micrometers.
2,800 micrometers. Always be ready for that. All right. I'm going to let you do the next one on your own. I want you to do the height. The height of the ball box. Try to go right in the middle.
Looks the same as the length.
Or you can just use the measurement of the cone.
Yes.
Dear.
What?
Can you just measure the quality bar?
No, because that's kind of going like outside a little bit. I would go right in the middle of that ball box.
I'd say 54.
I'm measuring.
I agree with you, Alex.
I did 54 at home, so
Yeah.
want to go with that? Good. Make sure you understand how we got 54.
Alright.
Okay.
So that's 54 over 150. Yeah, 54. Yeah.
There are worms in your arms. There are worms in your arms. Get them out.
Which is just 54 divided by 'Cause look what we did here, 56 divided by 2. Okay, yeah. I just skipped.
I think I did that one right.
You think?
Actually, these two I did like a long time ago, so.
What's 54 divided by 150?
I don't know. Alex. You tell me.
I don't know, but you tell me.
All right, I got you. 0.36.
Would it be silly?
Dude, you're a copycat.
What? And I got that one wrong too. What was wrong with my brain when I did these? I wrote it all out right. I don't know. What?
36.36.
I would go to 2 decimal places. That's what I would do until I teach you the rules.
No, I mean, but should we round it? Because it's 0.36.
Yeah, I would just do that.
Just round it
So, what is our size of specimen?
54 millimeters.
Shut up.
0.36
or
millimeters.
300
Oh, wait.
Yeah.
Or 3,600 micrometers.
No, it'd be like,
I will make it clear in the question what I want. I might want one or the other or both.
it'd be only 360 micrometers.
My bad.
Mrs. Sierra trying to mess us up.
There's so far is
360.
third trade.
360. Okay, we have time to do one more of the hard ones, yes?
No.
Yes.
No.
And we're gonna actually do
Homo sapiens.
Where?
all right. We are gonna fill out because I would really like for you to practice through this whole packet. So here's what we're gonna do. Go to your Vorticella campanula.
I want to do Homo sapiens.
That's two. Yeah, there's.
What? 2 of them.
There's a
Okay, this one is gonna be another easy peasy. Okay, this one I want you to cross out the 50, and we're gonna do 30x.
Yay.
And I want you to put mag question mark. That's what we're finding. What's sorry?
What do you mean that?
What's the size of specimen? Question mark. Same down here. SOS question mark 15x.
What is it, Julia?
I want to cross out the scale marker.
Yes.
What are you measuring?
Yeah, so,
What are you measuring? Great question. You are measuring
the little cup.
Yep.
Oh,
And for your euglypha,
Do I do it until the?
we're doing the whole body.
are we including the cilia? Or
Yeah.
Nope.
All right. So
Oh, sorry. There you go.
68.
Okay.
Anyone got 33?
Don't actually do it. I need you to fill out your packet first.
Oh, all right. Sorry.
Go to your Philodina roseola. That one. We are finding the mag question mark. And I want you to measure the whole body minus the little extra feet tails. Okay. Interesting point. When you're doing the mag ones, it actually doesn't matter what you measure. But I don't want to confuse you with that right now. Next one, amoeba. We're going to do the length of the amoeba from one end to the other. Here. Okay. Next time I make these copies, I'll try to like draw it in. The only thing is if I draw in a line, you're probably not going to see it. So we'll have to draw in the lines out. Okay. Good?
Yeah.
Next, we're going to the diatom fragilia. Fragillaria. What are we measuring on this one? Size of specimen. I want 85x for your diatom. And I want 95x for your other diatom.
Wait. Where's that at?
On the back of the left page. All right. And as you can see, you've got individual cells kind of dotted there. So I want you guys to measure those. Yes. Cross out the scales. My bad.
What was the first number? 85?
85.
We're just measuring what?
Yep, the length of one individual cell on your fragillaria, and one individual cell on your asterionella. Don't worry, I won't test you on the names. I always just find that it's fun to try to pronounce them.
I'm gonna rip them out all
Okay, cool.
Cool.
What I will do, I want you to work on these. If you have time in another class, in advisory over the weekend, use these as your study guide. I will post an answer key
When do you want this?
on Google Classroom, and I will send you a reminder. Wait, we're not done.
This is it. When do you want this done again?
This is for you to study it. Oh, that I would like. Is that from your microscope? Yes.
Honey doesn't have the amoeba one.
Uh-oh, missing a page? There's plenty of other practice, so it should probably be okay. But if you want to send her a picture of yours worked out, that might be helpful.
I'll get it turned in on Tuesday.
All right, let's keep going because I want you guys to have lots of practice. I know it's almost time.
Yeah, we got a minute.
Mag on this one. And you're measuring the individual cell here.
You look like
Mag on this one. And one cell body.
that one looks like something.
Ready, go, ready, go.
Looks like no, the section.
That's it.
It looks like
I'm going to go all the way. I suggest you guys stay and go all the way with me. All the way to the end of the packet.
I know.
Here's your stentor. We're doing actual size on these two. Cross out your scale bars.
Oh, let's go.
Size of specimen from 40x. And your size of specimen from 35x.
balloon man.
Your giardia there on the bottom. Aren't they cute?
Is that it?
What are we measuring? Good question.
Just the body.
Let's do the length.
Let's do the bottom one. It looks like a little bit.
Not including the cilia this time. Length. And actually, let's do this one over here. So this would be a great thing to do if you had any like extra time in class or anything like that.
Okay.
Good? Good? Moving on? We'll stop there. Okay, the last two, you can do whatever you want if you want to practice. If you want to practice on the last two, just do mag and pick a length. You can, but then you'd have to pick a mag. Here's some progress. Oh, thank you. Yes.
Right now.